Right, so we're talking about averages. In fact, there are four. What's wrong? What's the problem?
You know, he keep forgetting to buy a new one.
No, I ordered it.
From China?
No, the principal's going to get one from the IT department.
In Griffith?
Yeah.
And how long is it going to take? 3-4 days? Week?
Yeah.
To walk from that room to the IT department?
Probably. Right.
It's a long process.
Yeah.
It's not even going to be like more than €5. Less than €5.
Maybe. Oh no, these are expensive in the shop, 10 or 12.
Yeah.
Alright, so we know this word averages. Let's make that a bit bigger. So what are averages? Have you done? I know you've done these in physics and chemistry as well, but in fact there are 4 types of averages.
Wow.
So the first type, do you know any of the types? We have mean average.
Yes. Range average.
Where is your pad?
I don't need it for this. I'll be using the spreadsheet. Mean average, median average. What else is there?
Range average.
No.
Mode
average. What is the range average? You're just making up words. And the last one we'll call the mid.
Average. Yes.
Yes. Good job on reading. All right. So we have these 4 types. So write them down, and then we'll explain each one. Oh, and well, actually, there's a 5th one we'll have a look at today as well. You got them?
Yeah.
So the first one, the mean average. Which one's that now?
The normal average.
Yeah, but how do you find it?
And everything divided by the total number of what's there.
Yeah, so it's the sum of the data divided by n. Right? You know this one, don't you?
Yeah.
The one you normally use.
Yes.
Do you use this in chemistry? For the lab reports or anything?
Probably.
No, did you?
No.
Just in physics lab report? Yeah?
Yes.
Okay. Now, this is new, so this one is old news. You know this one from elementary school. But maybe you don't know this one, or maybe someone does. Median average?
No, I don't.
No, you don't know this one?
Average of all the middle numbers.
No? Thought somebody would know this. No? The number or the element.
The one before and after.
No. The number in the middle of the data when the data is ordered.
No, that's it.
No.
No, like.
No, you didn't.
When it's an odd number, you have to add the 2
But
in the middle
no.
to get the average.
Yeah.
But that's not the answer to what the median is. That's what you do to get the median when it's odd. You know? What's a car? Well, when you need to turn left, you put the steering wheel to the left. Like, how's that an answer to what's a car? So the median, or what you do, is you write the numbers in order from smallest to biggest, and the median is the one in the middle.
And can be the other way around.
Yeah. Okay, you got that?
Yeah. So
Right.
average.
Mode average.
Oh, no.
What's the mode average? Does anyone know that?
No.
39.
No, do you know?
The
Higher?
average.
No.
Not highest.
Lowercase uppercase? No.
What? No. The mode average, the number which is most frequent. In other words, the most common number.
Isn't that just mode?
Yeah, the mode average.
Just plain mode.
Yeah, and you can call the mean average the mean and the median average the median, but the full name is the mode average. What? Hey. You got that?
Yeah.
Yeah. What do you think, KJ, the midpoint average is?
The midpoint of like class boundary.
Any ideas?
Maybe the whole midpoint. All the midpoint of all the class.
Or maybe it could be the midpoint of all the averages? Midpoint average? The midpoint average is the minimum value in the data plus the maximum value in the data divided by 2. Yeah? And the weighted average, this is the sum of the data times their weights. Divided by the total weight. Now I'll explain these with examples, okay? So we'll do examples now in a moment. Yeah? Right, can we go then to an example? So here's our first example. So we'll have 5, 4, 6, 6, 7, 1, 0, 8, 6,
You just
5.
read the number from your head.
Yes. So here is our data. Okay, so the first thing I want you to do is get me the nice, simple, straightforward mean. So you want to add these all up and divide by 10. Whoever gets this first, Karar will buy them an ice cream.
4.1.
Final answer?
4.8.
So if you add them all up and divide by 10, 4.8. Yeah. Yeah. Okay.
Wait.
The program's not going to make a mistake here.
No, I just like to know my mistake.
Alright, so the next one, I want you to try and get me the median, please.
Medium?
Median, yeah.
You have to rearrange.
Yes, you have to rearrange these first. So that's what you need to do. Get to it. So for the median, put them in order from smallest to largest.
It's repeated. So
Yeah, just repeat it again.
Can you increase the size?
KJ, please buy some glasses.
You know it's a different color, so it's
But that doesn't matter.
blending with the color.
I'm looking at this and it looks perfectly fine.
You're closer to it. Plus you have better eyesight.
How's that?
Yes. You only increase the size of one.
Everything.
Okay.
Goodness. If I make it any bigger, it won't fit on the screen.
5.5.
Now let's see. So first thing I'm going to do is put them in order. So let's order these from smallest to biggest, okay? Data, sort, and we'll put them ascending. So you have 10 numbers. What's the middle of 10 numbers? No, actually the 5th and 6th.
Yeah.
Because think about it, if you have 4 numbers, the middle is not the second, it's not the third, it's the second and the third together. It's only if you have 3 numbers, what's the middle?
That, yeah.
The second.
Second,
And if you have 5 numbers, what's the middle?
the second.
Third. But if you have 10 numbers, the middle is the 5th and the 6th.
Now we have 11.
No, 10.
Okay.
1, 2, 3, 4, 5 and 6. So here's the middle here, these two. Yeah, so you can't use 5, you can't use 6. You use the middle of 5 and 6, which is 5.5. Okay, what's the mode here?
Six.
It's 6. It's repeated the most. And then the midpoint?
4,
8.
4.
It's 0 plus 8 divided by 2, which is 4. Do you get it? Is that okay?
Yes.
Is it?
Yeah, sure.
Now, what I'm going to do now, I'm going to add in weights. So weights represent how important the number is. An example would be when you're calculating your final maths grade, you know that each assignment has a different weight. Like, for example, 10% for the first one and 10% for the second one, okay? They don't have to be percentages, the weights. They could be any number that just represents their importance. So, for example, imagine that this data was from some kind of experiment. Sometimes, when you perform an experiment, some results are more accurate than others because maybe you realized during the middle of the experiment the machine was slightly off or whatever. So you want to give more weight to the other numbers because they're more accurate, for example. So for example here, let's say these numbers have a weight of 1, and then these numbers would say has a weight of 2, and then we'd say this number here, for whatever reason it's the most important one, we give it the most weight of 5. So these are the weights. So the weight just represents how valuable the data point is, its importance. So if you want to calculate the weighted average, what you need to do is multiply all the numbers by their weight. So here I'll write xf, this is like x. So it'll be equal 0 multiply 1. So 0 next, 2, 8. So you add these all up, and you get 94 divided by the total weight. So we need to get the total weight now. So the total weight is 17. Which one? Thank you. The total weight is 18. So the weighted average, that would equal 94 divided by 18. The total, the data multiplied by the weights divided by the total weight. So I get 5.22.
My calculator is 5.444.
94 divided by 18? Come on, do you think Excel is going to do this wrong? Now, I can understand you feel like maybe I do things wrong, which is fine, but you can't accuse Excel of doing it wrong.
No.
Yes,
I don't really understand what.
the weighted one?
Yeah.
What you do is you're given weights with the data.
Okay, so this is the data and this is the weight.
Yes, and this is given to you,
Okay.
and then you multiply the data by the weight, and I put the results here.
Okay.
So these are all the data multiplied by the weight,
Okay.
and here's the total right here. I'll put it in bold. That's
Total of the
this.
Okay.
And here's the total of the weights,
Okay.
and you divide.
Divide by
94 divided by 18.
Okay.
Okay, can you write that down as an example of weighted average? Got this? Yeah?
Yeah.
So are we clear on how to calculate the mean, median, mode, midpoint, and weighted average? This is an example when you're given a list of data. KJ, please. Are we clear about how to get these? Yeah. Now what we'll do next, there's two more examples to do. So we need to look at when we have a frequency table. So for example, here is X and here is F. So maybe X could be 0, 1, 2, or 3. And let's say you have 5 of these, 4 of these, 2 of these, and 1 of these. So X could be whatever, number of siblings, number of cars, yeah, number of homes, whatever.
Number of your A-star.
Number of A stars.
Yeah. 6 zeros, that's 5.
Yeah, that's true actually. Yeah, this is my class. This maybe could be like 4 in January or something. Anyways, whatever X is, we'll put in, whatever X is, it doesn't matter. X could be number of siblings, number of brothers, for example. So what this table means, you have 5 which have no brothers, 4 which have 1 brother, 2 which have 2 brothers, and 1 which has 3 brothers. We want the average number of brothers, for example. So here you realize, okay, so that's like 0 plus 0 plus 0 plus 0 plus 0, 5 times, plus 1, 1, 1, 1, plus 2, 2, plus 3. Because this is the data. How many zeros do you have? 5. So it's like 1, 2, 3, 4, 5. And how many ones? 1, 2, 3, 4. And then how many twos? 2, 2. And how many threes? 1. So you could average all of these numbers. But you realize, oh, because the number is repeated, I can do this quicker by just multiplying. So, instead of doing 1 plus 1 plus 1 plus 1, that's 4. Multiply 1. And instead of doing 2 plus 2, that's 2 multiply 2. So you don't really add them all together, you can multiply. So you can do 5 times 0, which is 0. 1 times 4, 4, 4, 3. So if you add them up, what do you get? 11. And then you need to divide it by, how many data points do you have?
5 plus
12.
12.
So divided by 12. So the answer is 11 divided by 12.
0.9167.
What is it?
0.91.
So, what?
What?
That doesn't even make sense that it changed to a date. Right, there's the average there. So this is a little bit like what? It's a bit like weighted averages,
Yes.
except in this case, what are the weights?
The tally.
Yeah, the tally, the frequency. Okay, so that's the mean average. What's the mode average here? So this is the mean. What's the mode?
Zero.
0. Why is that? Yes. How many times? 5. What's the median average?
1.
Yeah, how many numbers do you have? How many data points? 12, isn't it? So the middle will be between 6 and 7. So the first 5 numbers are here. Where's the 6th number and the 7th number? It's in this box.
How many data do you have?
12.
Why?
5 plus 4 plus 2 plus 1. Yeah? KJ. Are you sure? You have 5 of these, 4 of these, 2 of these, 1 of these. You have 12 altogether. So the 6th and the 7th, which is in this box. 5 of them are, the first 5 are here, the 6th and the 7th one is in the next box. Yeah? So the median is 1. Now, what about the midpoint?
That is
1.5.
Thank you, 1.5, because the biggest number is 3 and the smallest number is 0. The middle of 3 and 0 is 1.5. So this is the mean mode and the median and the midpoint.
The mean mode is, the median mode is.
exactly the weighted average.
I would have to give you weights here, but the frequency is like the weight, so we wouldn't usually have weighted average for these problems. You only have weighted average usually when they give you a list of numbers and their weights. Yeah?
The median was 1.
Yeah. Can I just clear this? Alright, so I want you to try this one, but it's a little bit different. I want you to think about how you might do it. So here, this is 0 to 1. This is, no, let's say 0 to 2, 3 to 5, 3 to 5, 6 to 8, would say. 6 to 8, and this one here, 9 to 11. And we'll make this 6, 5, 3, and 2. So what I want you to do here is get the average of these numbers. Now the first problem is you have 6 of what? You have 6 numbers that are between 0 and...
So we need to take class with.
Not 0 and 2. 0 and...
1.9.
No.
So you're asking.
2.9.
2.5.
Why?
Because of what we did this morning.
Yeah.
Yeah?
Yeah.
So you have 6 numbers between 0 and 2.5. Do you know what these numbers are?
No.
No. So you have to estimate. So if you have a number between 0 and 2.5, what's the best estimate for what that number could be?
Mid.
The midpoint.
That's the class.
What's the middle of 2.5 and 0? 1.25, isn't it?
Yeah.
What's the middle of 2.5 and 5.5? It's 4. Yeah. 5.5 and 8.5? It's 7. And 8.5 and 12? 10. So in this example, you have to estimate. You say that you have 6 numbers which are about 1.25. You have 5 numbers which are about 4. You You have three numbers which are about 7 and two numbers which are about 10. So how many numbers do you have altogether actually? That's 11, 16, isn't it? You have 16 numbers actually. 6 of them are this, 5 are this, 3 are this, and 2 are this. Do you understand? Yeah. So what I want you to do for me now is to get me the mean, median, mode, and midpoint. What do you need, Demi? You can just use your phone this time.
Last question by the origin from what I get? You done already?
One of the teachers who had to leave early today for an appointment, I said, well, if you get the appointment finished early, you can enjoy the sun and sit in your hammock, because he has a hammock in the back garden. You know a hammock? The thing you lie in that hangs between the trees? So he just sent me a text saying, taking your advice, I'm lying in the hammock right now.
But if you come back from more.
Well, the thing is, his appointment, he didn't know how long it would be, so... You know, when you have a hospital appointment, sometimes you don't feel like having to come back. So, he's just wanted me to know that he's lying in the hammock right now.
6 plus 5 is what?
Oh my goodness. Let me make that a bit bigger. Can you see this, KJ?
Yes.
I'd hope so.
Remove the highlight from it. Yes.
Have you got this calculated, Carl?
Yeah, getting there.
Yep.
Yeah?
So, this is the last.
Right. So the mean. How many 1.25s do you have? 6. So we have 6 times 1.25. How many 4s do you have? 5 of them. So 5 times 4, that's 20 in total. How many 7s? 3, so that's 21. And how many 10s? 2. And how many numbers altogether? 16, wasn't it? So 4.28?
Yes.
Great. The median. If you have 16 numbers, the median will be between what one? The 8 and the 9th. 16. Wait, 16. 8 and 9th.
Or 7 and 8.
Um,
Or something.
nothing. 16th is 8 and 9th. 8 and 9th. So the 6th number finishes here. The 7, 8 and 9th, they're all in this class. So the median I'm estimating as 4. What's the mode?
1.25.
Yeah. 1.25. And what's the midpoint?
5.
It'll be 11.25 divided by 2, 5.625. Did you get these? Yeah?
Wait, this,
What?
how do you get 5 points? No,
How do I get what?
5.625.
The biggest plus the smallest divided by 2.
10 plus 1.25.
Yeah.
Okay.
Yeah, is it okay? Is it?
That's annoying.
What?
Chapter.
No, it's not. It's much. You'd much rather have this in the exam than integration of improper partial fractions. Right? Let me show you something here.
Yes. We think so.
Okay. Why would we have mean, median, and mode anyways? So, let's have a look at some different types of data. Okay.
Lowercase and uppercase, please.
Your what?
Yes.
Lowercase and uppercase.
Lowercase and uppercase? What do you mean lowercase and uppercase? I don't think this is the word you mean. Lowercase and uppercase?
No, lower boundary and upper boundary. Upper class, yes. Lower class and upper class.
No, you're right the first time.
No.
Is this what you mean?
Yes, yes.
That's not uppercase, lowercase. That's something.
We use lowercase and uppercase like in more median.
This is class.
No, it has to be class or boundary, because uppercase and lowercase just means big letter, small letter. I know you know that. That's why I'm confused. Do you mean boundary or class?
Or quarter.
It was with more median, I don't know.
Mean, median, mode. No, we just really care about the midpoint. Now you might need, well, you need to find the upper and the lower boundary to get the midpoint.
Midpoint is 50% and lower case is 25%.
No, they're called quartiles. Upper quartile, lower quartile. Not uppercase, lowercase.
75%,
Yeah.
Yes.
Yeah. Right, let's have a look at some data, for example. So if you take something like income, so maybe you have one person who earns 20,000 a year.
Woo.
That's really bad, actually. 20,000 a year. 20,000 a year.
Double it.
30,000 a year.
Not even
30,000 a
like
year.
60.
30,000 a year. No, hang on.
100,000 a year.
Yeah.
How many 20s have I got? 4, is it?
Yeah.
30,000.
70,000.
70,000. No. We'll make a 40. We'll make a 60, and then we'll make a million.
Woo!
Here.
Yeah.
Yeah, over here.
So let's get. Can you calculate the mean, the median, and the mode? Well, we can do the mean, median, and mode, and the midpoint together. So what is the midpoint? That will be 20,000 plus
1
million
divided by
divided by 2. So that's 510,000. What's the mode? 20,000. The median?
23.
No, it'd be between the 5th and the 6th.
which is
So 3,000.
30 and 30.
30,000.
So the median is 30,000. Now calculate the mean, please. KJ, get calculating. Calculating.
370,000.
No.
Why would it do that? Why would it do that?
Tell you with the format.
Yeah, but why would it think that that number could be a date? Number format number. No, it's just not big enough there.
Yes, I got it.
Right, so let me just actually, it'd be nice. KJ. Right, so if you were to look at these numbers, consider this. The mean average is 127,000. The median is 30,000. The mode is 20,000. The mid is 510,000. These are all very different averages, aren't they? However, it's all the same data, true? So if I said the average is, that's not good enough. You have to say what type of average it is. If I said, oh, the mean average for these people is 127,000, that sounds really good, doesn't it? But is it accurate? Is it fair to say this group of people have an average of 127,000? Why not?
Because like only one person has like most have like 20,000.
Only one person even comes close to having this. So for data which is like income, which do you feel would be the most appropriate average to use?
More than median.
For example.
I think the median or the mode, but in particular the median, because the median represents the person who is literally in the middle. If you have more than their income, you're doing better than most people, and if you have less than their income, you're doing worse than most people. So the median here is 30,000. If you have more than 30,000, this is better than most people and less than 30,000. But why is mode also a suitable average to use?
Because shows the amount of people getting much poorer.
Yeah, but why would it be the most suitable?
Which one? Median?
Mode.
Mode. Which is the most repeated one?
Well, mode average is good because it's the biggest group of people with that income in your country. So, like for example, if I said the mode average in Ireland was 20,000, then that means most common wage people will receive is 20,000. So it means that if you travel to Ireland, the most likely wage maybe you'll have is 20,000 because most people have this. It doesn't mean you will have 20,000. It doesn't mean that there are more people with more than 20,000, but it's just the most common one. And this is important for countries where, you know, if the mode is very small, what would that mean about the country?
It's not very bad.
Not necessarily, no.
The people understand.
No, come on, think.
Don't go there.
No, don't just speak. Think before you speak. If the mode was quite small, what would that mean for the country?
They're paying a little low salary.
Not necessarily.
The
No, not necessarily. If the mode is quite small, it just means there's a big group in your country that receive the same wage, which is quite low, and this means, I'm not finished, this means that your country is probably very split. So if you have a big mode, if you have a small mode, it means there must be many people with this income. And if it's a small income, it means they're low income. Yeah? So this means that you probably have a country that has one part of society, they all get the same low amount, and another part which get more than this. Okay? If the mean, median, mode, and midpoint are all very different, what does this mean about the country? So like this country here, this is a country. These averages are all very different. Notice how the mean is much bigger than the median and the mode. So forget about the midpoint for the moment. What do you think that means for the country?
Means depends on.
You have like more groups in smaller islands.
Yeah, but give me some vocabulary that describes this country, this society. So the mean is a lot more than the median and the mode.
Majority and less.
Yes. And what's a word for that? Keep it simple.
Majority.
No. The concept you have that the majority earns.
People are lower than the.
No. Give me a word that describes this concept. It's an EAP word. Huh? No. True, but income inequality. Have you heard this before? I'm sure you have, haven't you? Yeah. So what happens if we make the richer person even richer? We make him a billionaire. Now, the mean average is 100 million euros. That sounds like a pretty good country. And then you realise, but you probably won't get this because most people get 20,000 and half the people get less than 30,000. So the bigger the mean is from these, the more unequal the society is. Do you understand? What?
Yes.
No, what's so funny? Seriously.
The number is very funny.
Will the data always be like this? No. In a lot of problems, these three numbers are about the same. But in examples of income, they're very different. This is important to know because the exam question it's very normal in the exam to ask you to calculate the mean, the median, and the mode. But the question then might ask you, which do you feel is the most appropriate average to use? So for income, what would be most appropriate? Well, people usually use the median. What about people's heights and weights? Mean. Can you think of an example where mode would be most appropriate? A situation where knowing what is most common is most appropriate.
Taste? No.
Yeah, you will know maybe. Be a bit more technical maybe though.
Type of food.
Yeah, but you want the data to be a number. I suppose you could say like you could have like food, I suppose, Chinese,
Yeah.
How many
Arabic,
people drink?
how many people.
Like drink per.
I think drinks may be the mode average. So, for example, you ask people how many drinks do they have per night. So you might have 0, 0, 1, 1, 1, 1, 2, 10. Something. Fine, 20. Why should you not use the mean?
Definitely to be
Why not use the mean?
drinking inequality.
Drinking inequality. Very good, yes. And the median is okay, but the mode is most important here because you can see that most people have one drink. So if you were designing some kind of promotion, some kind of special offer, you want to know what's the most common number of drinks people would have. So it's not like there's right and wrong averages, it's just some are better in different situations. Yeah?
Mm-hmm.
Let me just check now, I think that should be everything.
Yes.
So next time we'll have a look at standard deviation, which we kind of did in physics, a bit like the residuals.